Today is not a usual Minecraft video. This is a to teach symmetry of 3D shapes. Okay, I just could not find a good way to represent it other than using Minecraft. So yeah, we have some shapes here. One is a cuboid, a prisms, trapezoids. Trust me, this is a hexagon. I tried making a hexagon. It's just I want to make it tiny, to fit. But this is a hexagon. If you just trust me, a pyramid and a cylinder. Okay. Now don't worry about the cylinder. I will it's just for demonstration at the end. Okay. To make a point. Okay. Let's start by doing like, subscribe and share, and let's start. One is planes of symmetry. What are the planes of symmetry? Okay, they are basically, if we took this and like do this, so we get two same congruent shapes. Okay, this is the same and this is the same. It is that the rotation it just would be different. Okay, for here, though it's a bit tricky to make in these, but let me first make all of the lines of planes of symmetry for this. Okay, if we see, okay, you can see like, yeah, if we cut the thingy by this axis, we indeed get the same shape. Okay, a cuboid has three planes of symmetry. Okay, one is the going right through it. Okay, on this face, one is going right through it on the same face, and one is going through it like so. Now see, it's the same thing. Now here it's just very easy. For these prisms, what is the general way to know how many symmetry do they have? And they all share one line of symmetry. One is this line, like right across the their what do you call them, the heights technically, oh my god, where is even the selection? Yeah, this, see, it cuts it into two halves like so. So this is this plane of symmetry. This is one. What about the rest? Well, on these, they are the planes and the symmetry lines on the normal shape. Okay, on the normal shape. Like for a pentagon, it's like this. One would be going like so, and then one would be going from these edges as well. Okay, just trust me on these ones. You get the picture. Okay, so this will be 5, this will be 3, from here to here, here to here, and then one straight down the middle like so. 1, 2, 3, and then this one, last one, 4. Okay, so the point is there are n plus 1 lines of axes of symmetries in a prism. Only in a prism. Okay, one and the n is the amount of lines of symmetry in the cross-sectional cross-sectional area shape, and then one more is the height, the girth, I mean the length of it. Yeah, this is called the length. Okay, so this next for pyramids, and this is just like a circle. Since this is a circle, it has infinite, so you do not talk about this. Okay, for a pyramid you do not have anything regarding regarding this axis. Okay, we do not need to do anything special. If this is like a pyramid or like a those triangle base pyramids, that one, it won't work. Oh my god. Okay, it won't work because we just get a smaller pyramid in like a frustum weird, so it does not work. So how many lines are there then? And it's just only the base. How many lines of symmetry the base has instead. Okay, so this is a safe assumption. Okay, now for the for a square base pyramid, it has 4 lines of symmetry, one going like this way and one going this way. Yeah, you get it. If this is like a triangle, 3, square 4, pentagon 5, hexagon 6, blah blah blah, you get it is the same as this. So as many lines of symmetry the base shape has, that how many planes of symmetry a pyramid with base shape has, literally. So that's that. Next we have, now the final piece of the final thing here is axis of symmetries. It's very hard to show, and yeah, you just have to trust me on this one when I say it won't work quite as you wish to see it properly work. Okay, I might need like Axiom or 3D Decimals or something. Wait, let me pull up 3D Decimals, I think.